Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with the same module, that is the distributed database concepts or distributed database design, and the same chapter, that is chapter number 19, that is the distributed systems. In the last class, that is in the Friday's class, we have discussed some topics of the distributed databases. Now I'm going to continue with the same chapter but the new concept, that is a cloud-based databases. So let's start with the cloud-based databases. What is a cloud-based database and how to use a cloud-based database. So let's start the session. So first of all, some introduction about what we have covered in the last class. So we have covered in this chapter till now what is the distributed databases, how to use the distributed databases, what is the concept, what is the logic behind the distributed databases, how to use the distributed databases, and what is the advantage of distributed databases, what are the limitations of distributed databases, and what are the various benefits that is available in the distributed databases. So let's start with the next session. Let's start with the important topic, that is a cloud-based database. So let's start the session. Cloud-based is a relatively a new concept in the computing. So it is a new concept that is available, that emerged the late 1990 and 2000. First under the name software as a service. So this is the name that is given to the cloud-based database, that is software as a service. Initial vendors of the software services provide specific customizable application that they hosted on their own machines. That is, a cloud-based computing is available on their own machine. So cloud computing is a new concept that is used in a computing environment, that is also known as a software as a practice or software as a service, that is available in the initial phase of the vendors, initial phase of the producers. So initial vendors of the software services provide specific customizable application that they are hosted on their own machine. That is, first of all, that cloud computing is available on their specific application on their specific customizable application that is hosted on their own machines. The concept of cloud computing developed as vendors began to offer generic computer as a service on which clients could run software application of their choosing. That is, first of all, they develop the service, they develop the client that is available. Then various applications are also available on the various hosting on various clients, that is also available on the various choosing part. A client can make arrangement with a cloud computing vendor to obtain a certain number of machines, have a capacity of certain amount of data storage that is available. Both the numbers and the machines of the both the numbers of the machines and the amount of storage can grow and shrink as needed. So whenever there is requirement, there is need of the requirement, there is a need of the storage, that with the automatic the machines are increased and the number of the storage can also grow and shrink as needed. In addition to providing the computing services, many vendors also provide other services such as data storage services, map services, and other services that can be accessed using a web service application programming interface. So in addition to the computing services, many vendors also provide other services that is available in the data storage services, for example map services, other services that can be accessed using the web service application programming interface. Many enterprises are finding the need of cloud computing and services beneficial. It saves client and enterprise the need to maintain a large system support staff and allows new enterprise to begin the operation without having the large front-end capital investment in the computing system. So it is used with, or it can be developed with the help of the small amount of data, small amount of money that is required. So there is no huge investment that is available in the computing system. Further, as the needs of the enterprise grow, many resources can be added as required. The cloud computing vendor generally have a large number of cluster of the computer that is used, making it easy for the vendor to allocate the resources whenever there is demand of the resources. And web applications that need to store and retrieve the data for very large applications of users have been major driver of cloud-based databases. The need of these applications differ from those of the traditional database applications, and since their value, availability, scalability vary from time to time from we can say the data to data. Now, how the data will be stored in a cloud computing. So now next topic is the data storage system on the cloud. So that is how the data will be stored on the cloud computing. So applications on the web have high scalability requirements. So whatever the application that is required on the web, that is required on the internet, so that have extremely high scalability requirements. So their requirement is very high. Popular applications have millions of users. That is, for example, you are using internet, I am using internet. So there are number of elements that is required to use the internet. So popular applications have millions of users. Many applications have seen their load increase manifold within a single year or even within a few months. To handle the data management needs of such application, the data must be partitioned across thousands of processes. So data must be partitioned, or they say that data must be processed or maybe divided into multiple or number of processes that is used. So in order to handle the various data items, so in order to handle the data on the web that have a scalability requirement, so the data will be divided into multiple users, into multiple machines. A number of systems for data storage on the cloud have been developed and deployed over the past few years to address data management requirement of such applications that include Bigtable from Google, Simple Storage Services from Amazon, which provides a web interface to the Dynamo, which is value storage system, then Cassandra from the Facebook, which is similar to the Bigtable, and Shownet for the from the Yahoo. So these are the various cloud computing objects, cloud computing databases that is available for the data storage of various applications. In this chapter, we provide an overview of the architecture of such storage devices or such data storage system that is available in the database management system. Although some poor refers to the system as distributed database system, and they do not provide many of the features which are viewed on a database system today, such as support for SQL or transaction with the ACID property. Some people refer this system as a very we can say the distributed database system, and also applied the ACID property, that is the atomicity, consistency, isolation, and the durability. Now next is data representation, that is how to represent the data, that is the data representation. So as an example of data management needs of the web applications, consider the file of the or profile of a user, which need to be accessible to a number of various applications. So the user can be accessible, or that needs to be accessible to a number of different applications that are run by an organization. The profile contains a variety of attributes, and there are frequent addition to the attributes stored in the profile. So there are multiple attributes, multiple addition that is used in the specific profile to do the specification, that is how to use the attribute or how to add the attribute in the profile. Some attributes may contain complex data. So some of the data that is required, that is a very complex data. A simple relational representation is often not sufficient for the complex data. So there is a simple representation that is not suitable, that is not okay for the complex data. So data representation is very crucial in representing the data. Some cloud-based data storage systems support XML for representing such complex data. Some of the cloud compute or cloud-based data storage system also support the XML, that is extensible markup language. Other supports the JavaScript object notation, that is the JSON representation, which has found increasing acceptance for the representing the complex data. So there are multiple complex data that is available that needs the acceptance for the data representation. The XML and the JSON representation provides facility in the set of the attributes that are recorded, maintained, as well as the type of these attributes. Yet others, such as the Bigtable, define their own data model for complex data, including support for records with a large number of optimum columns. So there are multiple columns that is used, or there are multiple, we can say the record that is used for the optimum columns. Further, many such applications or web applications either do not need extensive query language support, or at least can manage without such support. The primary mode of data access is required, that is used with the key, that is the index key is used, or the associated key is used, and to retrieve the data would be the user identifier. And there are applications that conceptually require, that conceptually need, that what is the data requirement, why we are using the data requirement, what is the use of the materialization that is used in the data requirements. Unfortunately, finding the set of friends and then querying each one to find their post may lead to the significant amount of delay when data is distributed among the various machines. This is JSON, that is JavaScript object notation, is a textual representation of complex data that is required, that is used in the database application, that is used for transmitting the data between the applications as well as to store the complex data. Data storage system typically allow the multiple versions of the data item to be stored. So some data item or some data storage systems also have a multiple versions of the data item that is to be stored in the database systems. Versions are often identified by the timestamp, but they may alternatively identified by their integer value. That is, they are also identified by their timestamp and also available with the integer value that is incremented or decremented whenever a new version of a data is created. Lookup can specify the required versions of the data item or can pick up the versions that is used with the highest version of the data value. So whatever the data value, whatever the big table contains, that is a contain that key consists of three parts. One is the record identifier, then attribute name and the timestamp. So a data identifier can be used for the timestamping that is used in the data identification. So there will be a record identifier, attribute name and the timestamp. Now next is the partitioning and the retrieving value. That is how to retrieve the value, how to partition the value. So partitioning and retrieving the data. So first of all, make the partition for storing the data, then retrieve the data from these partitions. So partitioning of data is of course the key to handle extremely large scale in data storage systems. Unlike regular parallel databases, it is usually not possible to decide on a partitioning function ahead of time. Further, if load increases, more servers need to be added and each server should be able to take on parts of the load incrementally. So whenever there will be a need, whenever the load increases, there will be a part of the increasement, the server need to be added. So automatically when the demand increases, the server will be added, the clients will be added and the requirement will be added. And each server should be able to take on the parts of the load incrementally. That is, one server will be added, another server will be added and so on till multiple servers will be added. To solve the problem, that is both these problems, data storage system typically partition the data into relatively small units. So the data storage system requires the partitioning the data to be in the small unit, that is the small on the such system I mean the order of the 100 of the megabytes. These partitions are known as the tablets. So whenever there will be a partition into various parts, that partitions are known as the tablets. So name of the partition are the tablets. That reflecting the fact that each table is a fragment of a table. That is, each table that is available is a fragment of a table. The partitioning of data should be done on the search key so that a request for a specific key value is directed to the single tablet. Otherwise, each request would require processing at multiple sites, increasing the load on the system greatly. And the two approaches that is used, that is either range partitioning that is available on the key or the hash function that is available or that is applied on the key. Now, the site to which the tablet is assigned acts as a master site for that tablet. So whatever the tablet that is required, whatever the site that is required, that is in which the tablet assigned or means the tablet is assigned acts as a master key for the application. No, for that tablet. All the updates that is routed through the sites or through these sites and updates are then propagated to replica of the type. So whatever the update that is required that is available with the site and that is required in the database management system to mode the requirement to use the requirement for the various sites. Lookup are also sent to the name site or same site so that the reads are consistent with the sites. The partitioning of data into tablets is not fixed up front. So the data is not available, is not fixed up front automatically. So this is the architecture of the client server architecture that is used, that is router, tablet server, master copy. Now next is the transactions and the replication. That is what are the various transactions and how to use a replication in the transactions. There will be a machine that is used as a cluster, that is a Google file system that is used for the clustering values. Now traditional databases on the cloud. That is what are the various traditional databases that is available on the cloud. So we now consider the issue of implementing a traditional database, distributed database system supporting the ACID property and the queries on a cloud. So there will be a requirement to compute, there will be a requirement to manage the databases, manage the distributed databases that is required to manage on the cloud computing that is used in the database management system. So the concept of computing utilities is an old one, enhanced back in the 1960s. So late in the 1960s, the concept of the virtual machines were developed in which a user was the illusion of having a private computer that is used in the cloud computing. Now, what are the challenges that is used with the cloud-based computing? So cloud-based databases certainly have several important advantages compared to building a computing infrastructure from the scratch, and in fact essential for certain applications. So these are the cloud-based database software that have this different disadvantages that is used. So by unlikely purely computation application in which the parallel computation run independently distributed, this database system requires fragment or frequent communication and coordination among sites. So what is the main requirement in case of the distributed system that requires a frequent communication and coordination among the sites? First one is access to data on the other physical machine, that is either because the data is owned by another virtual machine or because the data is stored on a storage server separate from the computer hosting the virtual machine. So whatever the data that is available, whatever the requirement that is available, that can be used to access the data on the physical machine or the renewing machine that is used with the virtual machine. Then obtaining the logs on the remote data. So whatever the logs that is available, that is also obtained by using the concept of, or we can say the computation applications are used for the parallel applications. Then next is the directory system. So what is the directory system? How we are using the directory system? So consider an organization that wishes to make data about its employees available to a variety of people in the organization. Suppose my requirement is that my each and every employee data is visible to each and every data or each and every person in the organization. So example of some kinds of data, that is what are the various example how the data will be available to the employee, or what type of data will be we can say the distributed among the employees. The data may include the name, designation, employee ID, address, email address, phone number, fax number, and so on. So in the pre-computerization days, organization would create physical directories of the employees and distribute them across the organization. So in the pre-computerization days, or in the previous days that is available, organization would create physical directories of the employees. That is, in the earlier days, the employees or the organization create the physical directories of the employees and distributed them among the various organizations. Even today, telephone companies create physical directory, that is we can say the hard copy directories of the employee. Each and every name is written in the book, that is a physical directory of the customers. In general, a directory is a listing of information about some class of object such as person. Suppose a directory contains information about a person like name, designation, employee ID, address, email ID, phone number, and so on, multiple information. Directories can be used to find information about a specific object, or in the reverse direction to find object that meets a certain requirement. In the world of physical telephone directories, directories that satisfy the lookup in the forward direction are known as the white pages. So whatever directories that require that satisfy the lookup in the forward direction, that is known as the white pages, while directories that satisfy the lookup in the reverse direction, that is known as the yellow pages. There are two types of pages that is available. One is the directories in the forward direction, one is the directories in the reverse direction. Forward direction directories are known as the white pages, and the reverse direction directories are known as the yellow pages. Now first is the directory access protocol, that is how to access the protocol, what are the various protocols that is used with the directory access. So directory information can be made available through web interfaces, as many organizations and phone companies in particular do. Such interfaces are good for the humans. However, programs too need to access directory information. Directories can be used for storing other types of information like file system directories, and web browser can also be used to store the personal bookmark and other browser setting in a directory system. Now, several directory access protocols have been developed to provide a standardized way of accessing the data in a directory. There are multiple directory access protocols that is used or that is developed to provide a standardized way of accessing the data in a directory. Standardized way means a proper method by which the data is available in the directory. The most widely used among them today is the lightweight directory access protocol, that is LDAP. Obviously, all the types of data in our example can be stored without much trouble in the database system and can access using the protocol such as JDBC or the ODBC, that is the Java database connectivity and the open database connectivity. Now these are the various questions, or these are the various answers to the question, that is why come up with a specialized protocol for accessing the directory information, that is what is the main advantage of using the protocol for accessing the information. First one is that directory access protocols are simplified protocols that cater to a limited type of access to a data. That is first point, that is answer to why we are using the specialized protocol. Second and most important, directory system provides a simple mechanism. So it is a very simple mechanism to name the objects to simple similar to the file system directory means, which can be used in a distributed directory environment. Now what is LDAP? That is a lightweight directory access protocol. That is a LDAP. So in general, a directory system is implemented as one or more servers. So whenever we use a directory system, that can be implemented as one or more server that will be used, which provides a client or multiple clients. Clients use the application programmer interface defined by the directory system to communicate with the directory services. So whatever the client or whatever the application program, whatever the interface that is used by the application programmer, that is defined by the directory system to communicate with the directory server. Now directory access protocols also defines a data model and access control. The X.500 directory access protocol that is used, that is defined by the International Organization for the Standardization, is a standard for accessing the information, directory information. However, the protocol is rather complex and not widely used, and the lightweight directory access protocol provides many of the X.400 features but with less complexity. So it is available with the less complexity that is used in the database system. That is a lightweight directory access protocol. Then LDAP data model. Now next is the LDAP data model. So in LDAP, directory stores entities. So whatever the LDAP that is used in this, the directories can store the information, they store the entries which are similar to the object. Now there is no use of the object, there is no use of file. Now the directories contain or the folders contains the entries which is similar to the objects. Each entry must have a DN, that is a distinguished name, that is a unique name which uniquely identifies the entry, and DN is done in the sequence of the relative distinguished name, that is RDN. For example, entries like this one, that is the CN, that is for Civil Chats, OU Computer Science, O Yale University, and the C USA. Now, how to manipulate the data in the LDAP? So that is the data manipulation language. So there will be a data manipulation language or the data definition language that is used in the LDAP like a SQL. So there is no, as per the standard definition or standard language that is defined for the data manipulation and the data definition. However, or we can say instead, LDAP defines a network protocol for carrying out the data definition and the manipulations. There is no, as such we can say the language that is used, but the LDAP defines a network protocol for carrying out the data definition and the manipulation. Users of LDAP can either use an application programming interface or use tools provided by the various vendors to perform data definition and the manipulation. So whoever the users of LDAP can either use an application programming interface or use the tools that is provided by the various vendors to perform the data definition and the manipulation. And LDAP also defines a file format that is known as the LDIF, that is a LDAP data interchange format that can be used for storing and exchanging the information. So whatever the data will be available, that is used for the storing and exchanging the information. The querying mechanism in LDAP is very simple, so consisting of just selection and the projection. So whatever the querying mechanism that is used, that is only used for the selection and the projection without any join operation. A query must specify the following. So what is the content of the query that is used? The first one is the base, that is a node within a DIT, by giving its distinguished name, that is a path from the root to the node. Then a search condition, then there will be a scope. The search condition means that may be a Boolean combination of the conditions on the individual attributes. Equality matching by wildcard characters and approximate quality that are supported. Then a scope, which can be just the base that is used, that is available in the database system. That is defined in the database systems. Now the next is the scope, that is just a base, the base and its children, or the entire strength of the base, that is the entire tree of the base that shows the hierarchy, that is the scope. Then attributes to return, that is what are the various attributes to return from the source file to the destination file. Then limits on the number of results and the result or resource consumption. So what are the various limits on the number of the results and what are the various resource consumption that is used in the database management system. The query can also specify where to automatically dereference the aliases if the aliases are turned off. These are the various URL that is available. The first URL defines all the attributes of all entities that are the server which organization being used. This is one of the example of this one. Then next is the distributed directory structure, that is how to use the distributed directory structure. What is the main advantage of distributed directory structure? Now this is the summary of this chapter. That is the crux of this chapter, that is a distributed database system or distributed database management system. So first topic is a distributed system consists of collection of sites, each of which contains or maintains a local database system. So distributed system contains various sites that contains multiple local database system that is used. So that is a distributed, that is the work is distributed among the various local database management systems. Each site is able to process local transactions, that is a transaction that access the data in only that single site. In addition, a site may participate in the execution of global transaction that is used at the various sites, that is a transaction that access the data in the several sites. The execution of global transactions require communication among the sites. So whatever the execution that is required, that is used for the various communication that is used with the various sites. Next point is distributed database may be homogeneous where all sites have a common schema. So any distributed databases that have a homogeneous, or that may be a homogeneous type, that is a similar database system that is used, and where all sites have a common schema, and the database system code, or the heterogeneous where the schema and the system code may differ. So the distributed system or distributed databases may be a homogeneous or may be a heterogeneous. Homogeneous means that same sites have or all the sites have a same schema, same interface, same architecture, and the heterogeneous means where the schema and the system codes are differ from each other. Next, there are various issues that can be involved in storing a relation in the distributed system, including the replication and the fragmentation. There are multiple issues how to store the data, that includes the replication, that includes the fragmentation. Then a distributed system may suffer from the same type of failures that can affect a centralized system. Then to ensure that atomicity, all the sites in which a transaction T executes must agree on the final outcome of the execution. T either commits on all the attributes or abort at the various sites. To ensure the property, the transaction coordinator of T must execute a commit protocol. The most widely used commit protocol is the two-phase commit protocol. So the most widely used protocol that is used is the two-phase commit protocol that is used with the database management system. Now, next is the two-phase commit protocol may lead to the blocking, the situation in which the fate of a transaction cannot be determined until a failed site recovers. So, two-phase commit protocol is used, that is used with the blocking sites, that is a condition, a situation in which the fate of a transaction cannot be determined until a failed site recover. Then next is persistent messages provides an alternative model for handling the distributed transactions. Next, the various concurrency control schemes used in centralized system can be modified for use in a distributed environment. So various concurrency control mechanisms, schemes that are also used in a centralized system can be modified for use in a distributed environment. In case of the logging protocol that is used, the only change that need to be incorporated is in the way where the log manager is implemented. Then the protocol that is used to handle the replicated data includes the primary copy, majority bias, and the quorum consensus protocols. In case of timestamping and the validation scheme, the only needed change is to develop a mechanism for generating the unique global timestamps. And most of database systems support lazy replication where updates are propagated to replica outside the scope of the transaction that performs the update. Such facility must be used with greater care since they may result in non-serializable executions. The next is deadlock detection that is used in the disk system requires the operation among various sites. And to increase the high availability, distributed database must detect the failures, reconfigure itself so that the computation may continue, recover whenever there will be a required. So next point is some of the distributed algorithm require the use of the coordinator. So there will be a requirement of the coordinator that is also used. And the queries on the distributed system may need to access the multiple sites. And heterogeneous system also allowed the multiple sites to use their own schema and then their code. Then a large number of data storage systems on the cloud have a built-in recent years. These are the review terms of this chapter. These are the various questions of this chapter. Now the next chapter is chapter number 20, that is going to start after the break. This is the bibliographic notes. So chapter number 20, that is the part number 6. First of all, data warehousing, data mining and the information retrieval. So how to warehouse the data, how to store the data, how to mine the data, and how to retrieve the information, that is the information retrieval. That is the data warehouse, data mining and the information retrieval. So that is the part number 6. So let's take a break right now, then move to this part number 6, that is the data warehousing, data mining and the information retrieval. So we have finished with part number 5 along with the chapter number 19, that is the distributed databases. So let's take a break right now. So come back from the break. Now let's start the session again. So let's start with the part number 6, that is the data warehousing, data mining and the information retrieval. So as the name advises, data warehousing, that is how to store the data, data mining, that is how to mine the data, and how to retrieve the information, that is the information retrieval. So this part contain, or part number 6 contain 3 parts, that is the data warehousing, data mining and the information retrieval. Those database queries are often designed to extract specific information such as the balance of an account or the sum of a customer's account balance. So that is a balance of an account that is available, or the sum of the customer account balance that is used in the customer account. However, queries designed to help formulate a corporate strategy and usually requires access to large amount of data originated in the multiple resources. So it uses the strategies that is used. There are multiple resources, there are multiple methods, or there are multiple, we can say, the options in which the data will be stored. So queries must be designed to help formulate a corporate strategy, usually requires access to large number of or large amount of data originated at the multiple sources. A data warehouse is a repository of data gathered from multiple sources and stored under a common unified database schema. So data warehouse means repository or storage of all the information of all the data that is gathered from various resources, from multiple resources. There are multiple resources that is available from the data. So every data is available from the multiple resources and stored under a common name that is known as the repository of the data, that is known as the data warehouse. And data stored in the warehouse are analyzed by the various statistical or complex aggregation method that is known as the data analysis, that is known as the data mining. So whenever the stored data can be analyzed in a statistical manner, in an aggregation manner, in a complex manner, that is known as the in data mining. And furthermore, information discovery technique can also be used to attempt to discover the rules and patterns from the files. For example, a retailer may discover a certain product that to be purchased together. We may information to develop the marketing strategies. This process of knowing or knowledge discovery from data is known as the data mining. So whenever we gain the knowledge from the data information, from the data and the information, that is known as the data mining. Chapter 20 addresses the various issues of the data warehouse and data mining. That is, what are the various issues, what are the various, we can say, the restrictions that is used with the data mining and data warehouse. In our discussion so far, we have focused on relatively simple, well-structured data. However, there is an enormous amount of unstructured textual data on the internet, on intranet, within an organization, on the computers of the individual users. Users wish to find relevant information from this vast body of the mostly textual information using simple query mechanism and such as the keyword query. So whatever the query that is used with the individual user, that is used with the mostly relevant information users. The field of information retrieval deals with querying of such unstructured data. So whatever the information that is required, whatever the information retrieval that is used with the unstructured data, and pays particular attention to the ranking of query results. So whatever the result of the query, whatever the ranking of the query, that is used with querying the result of the query. Although this area of research is several decades old, it has undergone tremendous growth with the development of the World Wide Web. And chapter 21 plays an introduction to the information retrieval, that is how to retrieve the information from the www or the internet. Now let's start with the chapter number 20, that is the data warehousing and the mining. So first of all, what is data warehousing? As I told you, that warehousing means storage. So whenever we store multiple data at the common place, that is known as the data warehousing. That is the repository of all the information at one place, that is known as the data warehousing. So businesses have begun to exploit the bargaining data online to make better decisions about their activities, such as what item to be stocked and how best to target customer to increase the sales. There are two aspects of or exploiting such data. So there are two ways by which we can exploit the data. The first aspect is to gather in data from multiple resources into central repository that is known as the various resources or data warehouse. So first aspect means gathering all the data from multiple sources, that is, or gathering the data from the multiple sources that is required and put at the one place that is known as the repository, or that is known as a central repository that is known as the data warehouse. And what are the issues, whatever the role that is involved in the warehouse includes technique for dealing with dirty data, that is the data with some errors, and with techniques for efficient storage and indexing of large volume of data. This also includes the challenges like how to deal with the dirty data, how to deal with the error data, how to use the techniques for efficient storage and the indexing of the large amount of data. The second aspect that is used, that is to analyze the gathered data and to find information or knowledge that can be based for the that can be used as a basis for the decision making. So first of all, gathering the data as a centralized location. Now after the gathering, after maintaining the data warehouse, now analyze the data very carefully for decisions or for business decisions. That is very crucial in case of a business making or business development. Some kinds of data manipulation can be done by using the SQL, that also uses the OLAP, that is online analytical data processing, which can be shown in section 5.6, and by using the tools and the graphical interfaces for OLAP. So we can either use the SQL, we can either use the OLAP. Another approach to getting the knowledge from data is to use data mining. That is another approach that is also used, that is the data mining, which aims at detecting various types of pattern in large amount of data. Data mining supplements various types of statistical techniques with minor or similar goals. So whatever the goal that is used with a similar goal that is used with the data mining. Now, first point is decision support system. That is, what is the decision support system? How we are using the decision support system? What is the main advantage of decision support system? That is also known as the DSS. That is the decision support systems. Database applications can be broadly classified into two categories. That is either the transaction processing system, either the decision support system. So the database applications can be divided into two categories. One is the database or decision support system. One is the transaction processing systems. Transaction processing systems are systems that record information about the transaction. So whatever the processing, whatever the transaction, whatever the information that is required about the transaction, that must be used for the transaction, that must be recorded with the transactions, such as product sales information for the companies, or the course registration and the grade information for the university. So whatever the transaction processing system that requires or that stores the information about the instructions about the transactions, such as the product sales information or course registration or the grade information for the universities. So any information related to the transaction that is stored in the transaction processing system. Transaction processing systems are widely used today, and many organizations have accumulated a vast amount of information gathered by these systems. Decision support systems aim to get high level information out of the detailed information. That is, next category is a decision support system that is used to make the decisions in the company, that helps a manager to decide what product is used or which product is used, what is the beneficial product, and how much is the beneficial to the organization, to the university, anything that is used. So that is basically generally used for the decision, that is a decision making or decision support system. For example, a company database often contain enormous quantities of information about the customer and the transaction. That is, there are so many information about the customer and the transaction, and the size of the information storage required may range up to 100 of gigabytes. That is, there are multiple information that is required. The transaction information for a retailer may include the name of the identifier, such as the credit card number of the customer, item purchased, item or price paid, and the date on which the purchase were made. Information about the items may include the name of the items, the manufacturers, model number, color, and the size. So whatever the information that is required, that is used with the database management system, that may include the name of the item, that may include the manufacturer, that may include the model number, that may include the color and the size. Customer information may include credit history, annual income, residence, age, and even education background. These are the information of the customer. Such large databases can be diverse or can be treasure troublesome information for making decision or for making business decisions, such as what item to stock and what discounts to offer. So that is a what item to stock, that is what item will be used or separate as a stock values, and what discount to be offered to the various public retailers. Now, the storage and the behavior or retrieval of data for decision support raises several issues. So, how to retrieve the data and how to store the data in the decision support system, and also raises several issues. The first issue is that although many decision support queries can be written in SQL, others either cannot be expressed in SQL or cannot be expressed easily in the SQLs. Several SQL extensions can or have therefore been proposed to make this data analyzer easier. So there are many databases, there are many extensions that is available that makes the data analysis easier. And there will be a technique that is used, that is the OLAP, that is online analytical data processing. The next point is distributed or database query languages are not suited to the performance of the detailed statistical analysis of data. There are several packages such as the SAS, S++ that helps in the statistical analysis. Such packages have been identified or interfaced with the database to allow large volume of data that is used in the database and retrieved efficiently for the analysis. That is the database query languages. Then large companies have also diverse source of data that they can use for making the decision. So whatever the decision that is used, whatever the thing that is used with the business decision that is used for supporting the business decisions. The sources may store the data under different schemes. For performance reasons, the data sources usually will not permit other parts of the company to retrieve the data on the demand. And to execute the query efficiently on such diverse data, companies have built data warehouse. The knowledge discovery technique that attempts to discover the automatically statistical rules and patterns from the data, and the field of data mining that combines knowledge discovery technique that is required by the artificial intelligence researchers and the statistical analysis with efficient implementation technique that enables to use on the large databases. The area of a decision support can be broadly viewed as covering all the above areas. So whatever the data house, whatever the decision support that is used with the various houses, various areas in which the various terms or which various data will be available in the statistical analysis and the data mining. Housing that I'm going to start in the next class. So that's all for today's session. Thank you so much everyone for listening me. In the next class, that is in tomorrow's class, I'm taking a next topic, that is data warehousing. So thanks a lot. Now if there is any doubt, any suggestions, any query, you can ask the doubts from me. So thanks a lot everyone. Bye bye.